As we stated in the previous video, all physical values have both a numerical value and a unit which combined shows a value's magnitude or size. However, for more complex values, an added description is required. Generally, when discussing physical values, there are two main types of quantities, scalar and vector quantities. Scalar quantities are values which only have a magnitude, while vector quantities are those with both magnitude and direction of motion. For starters, scalar quantities are values that only provide information about its size. For example, mass is a scalar quantity as it only tells us how much matter there is in a body. Other types of scalar quantities may include the following. On the contrary, vector quantities are those with a specific size and direction. What this means is that the magnitude illustrates how much the vector moves while direction illustrates where it moves. For example, acceleration is a vector quantity as the magnitude shows how fast a body accelerates, while a direction is necessary to understand where it's accelerating to. Other examples of vector quantities include the following. What we quickly notice is that most scalar quantities have vector counterparts which are easy to distinguish. The most common pair of quantities is distance and displacement. Distance is a scalar quantity as it indicates how far one moves from the starting point. On the other hand, displacement is a vector quantity as it shows the shortest straight line path between a body's initial position and its final position. Moreover, another difference to these quantities is their ability to be operated. Scalar quantities can be operated arithmetically by simple addition, subtraction, division, and multiplication. This is because these quantities are only magnitude. Vector quantities, on the other hand, are operated geometrically, taking into account their size. They are often represented by arrows, where the length of the arrow indicates its magnitude, and the direction of the pointer represents its direction. Now, with vectors, there are four main points that we must understand. 1. Vectors can be operated and compared through graphical depictions. For example, a longer arrow has a greater magnitude than a shorter arrow. Add them together and you get an even longer arrow. The same is true for subtraction. 2. Subtracted vectors create what is known as a resultant. A resultant is a single vector that represents two or more vectors. What this means is that when the vectors are acting against each other, the resultant is the difference between the two vectors. For example, if one vector is acting at 6 units to the right while the other is acting at 3 units to the left, the resultant is 3 units to the right. However, in situations where the two vectors act in different angles, you must be able to use the triangle method or head-to-tail method to find the resultant. This is done in easy steps. Firstly, draw out both vectors to scale in accordance with their directions. Then you place one of the vector's tails on the head of the other vector, hence the name head-to-tail. Make sure that both the length and angle of all your vectors remain constant. After that, you draw a line connecting the two vectors to create a closed vector. This line is your resultant, which you will measure to find its magnitude. The direction of the resultant correlates to the direction of the other vectors, which can be calculated using trigonometry. Note that you can do this method for any number of vectors greater than 1. 3. Any vector magnitude theta put against another vector magnitude negative theta has the same magnitude but opposing directions. This is because negatives indicate a 180-degree rotation in direction while keeping magnitude the same. 4. The sum of any two vectors which have opposing directions but the same magnitude will have no resultant as they will cancel each other. Any other situation will result in a resultant in a specific direction.